All right, welcome to lesson 4. This lesson is about negative exponents. So we've already learned in this unit all about radicals and how radicals can become exponents. The last part of this unit is exponent rules. So we're going to be using the exponent rules with fractional exponents. But before we can do that, we need to learn about the negative exponent rule. So this is a new one that you didn't learn about in grade 9. So we're going to go ahead and try to figure this guy out. So what I want you to do is take a look at the following. And we're going to analyze this by following the pattern, okay? So I don't want you to use your calculator. I want you to follow the pattern. So 2 to the power of 5 is 2 times 2 times 2 times 2 times 2. I think I have enough of them, maybe another 2. But that is 32, okay? 2 to the power of 4, so 2 times 2 is 4, times 2 is 8, times 2 is 16. All right, so let's do one more and then let's look at the pattern. 2 to the power of 3 means 2 times 2 times 2, which is 8. Okay, so now let's start analyzing the pattern. So if we look at 32 and then 16 and then 8, what are we doing between each step? Well, we are dividing by 2, right? We're dividing 2. So if we divide by 2 here, this guy's going to become 4, and we can double check it because we know that 2 times 2 is 4. And if we divide by 2 here, this will become 2, right? And then if we divide by 2 again, this becomes 1, because 2 divided by 2 is 1. You should have learned the 0 exponent rule in grade 9. Anything to the power of 0 is equal to 1. Now, if I divide this by 2, 1 divided by 2 is a half, but we're going to leave them as fractions, okay? And then if I go, now this is going to get a little bit trickier, a half divided by 2. So remember that a half divided by 2 is the same as a half times 1 over 2, which is 1 over 4. Okay, and then 2 to the negative 3. So if I divide a quarter by 2, it means a quarter times a half, which is 1/8. So you can kind of maybe see, so you can see what's happening to our denominator there. It's multiplying by 2. So this last one's going to be 1/16. Okay, let's try 3 to the power of 4. So if you need your calculator to get these first couple, so 3 to the times 3 is 9, times 3 is 27, times 3 is 81. 3 times 3 times 3, so 9 times 3 is 27. 3 times 3 is 9. So you can see here what I'm doing is I am dividing by 3 each time. So we're always dividing by whatever that base is, right? So 9 divided by 3 is 3. 3 divided by 3 is 1. 1 divided by 3 is 1/3. 1/3 divided by 3 is going to be 1/9. 1/9 divided by 3 is going to be 1/27. And 1/27 divided by 3 is going to be 1 over 81. And 1 over 81 divided by 3 is going to be 1 over 243. Now, if you look at these, what we maybe hopefully notice is that 3 to the negative 2 is the same as 1 over 3 to the positive 2. So when I have a negative exponent, I just like evaluate that exponent, but I put it in the denominator of the fraction, right? So we know that 3 to the 2, or sorry, negative 2 is equal to 1 over 3 to the positive 2, as an example. And this, in fact, is the negative exponent rule. The negative exponent rule that says that when I have x to the negative m, it is 1 over x to the positive m. I like to call this the up-down rule. Basically, if the exponent is negative, you move it to the opposite part of the fraction, so either numerator or denominator, and then change the exponent to a positive number. So if it's negative in the top, I put it in the bottom. If it's negative in the bottom, I put it in the top. Let's look at a couple of examples so I can show you what I mean. So this 2 to the negative 3 is going to be the same as 1 over 2 to the positive 3. All this is asking me to do is write with positive exponents. I don't need to evaluate it, just leave it as positive exponents. Here, 3 to the negative 3 in the bottom, so I move it to the top, and it becomes 3 to the positive 3, sorry. In number 3, So when there's more than one base happening here, what I like to do is identify the ones that need to move. Okay, so this one, the 5 to the 4 is positive. I'm going to leave it where it's at. But the 3 to the -2 is negative on the top, so I need to move it down to the bottom. That leaves me nothing on the top, so I need a 1. Okay, let's look at some containing variables or a little bit more complicated examples. So when you look at number 4, you might be a little bit afraid. I'm going to make this a bit bigger here, but don't be afraid. So my strategy is this. Go through and identify all the things that need to move. So all the things that are negative exponents. So this guy, that guy, and that guy. Okay, so the m and the r are going to stay where they are. So write those down. M to the 3, r to the 5. Those stay because they're positive where they're at. The other ones I need to change. So the n to the -2, which is on the top, is going to come down to the bottom and become positive. So it'll become n to the +2. The p to the -2, which is in the top, will come down to the bottom and become positive. And the t to the -3, which is in the bottom, will go to the top and become positive. Now, important to note that it does not matter what order you write these in, okay? It really makes no difference. I think traditionally they would be kind of an alphabetical order. So I think LMNOP, I think it would be NPR, but it doesn't matter, like as long as you have the exponents correct. Okay, let's look at number 5, 2m to the -3. So this is a common one where people will often take the whole thing and move it down, but you need to remember that the exponent is only on the thing that it's touching. So it's only actually on the m. The 2 is going to stay where it is up top, and the m is going to move. Okay, so this is not moving the whole thing down. Okay, that is incorrect, but that is a very common mistake. So remember that the exponent is only on the base that it is touching, not the entire thing. If you had something that looked like this, then you could move the whole thing down to the bottom and make it positive, okay? But that's not what we have. So let's not get confused by that. Let's look at question number 6. So one more example. Okay, so now this brings in a rule from before. So when we have an exponent on the outside, we need to put it to both of those things. So it becomes 2 to the -5 over 3 to the -5. And then I need to exchange places with it because the 2 needs to come down to the bottom and become positive, and the top 3 needs to go to the top. So I have 3 to the 5 over 2 to the 5, which is the same as 3 over 2 to the 5, but you could just leave it either way. So what we notice, if we take a look at my question and my answer. So when I have a fractional base, okay, when I have a fractional base, let's maybe write ourselves a little rule here. It's a variation on the rule. Okay, so if I have x over y to the -m, let's say, what we can do is we can flip it. This will become, so if you notice it was 2 over 3 in my question up here, and now it's 3 over 2. So I reciprocal my base, so y over x, and then my exponent becomes positive. Okay, so if you remember that rule, great. It's a kind of a shortcut rule. You can always just distribute through the bracket and then make them positive, but it is a shortcut rule. But okay, so I want you to go ahead and practice on the questions that are below, and then we'll see how you do.